3 out of 4 for the weekend day. God, this band is fucking crazy. They recently got a, been listening to them for like, I don't know, a week or two maybe. They recently got a singer. Oh wait, this isn't even her. Fuck! God, embarrassing. It's not even the same person. Yikes. Oh no. Wait, what are the... Wait! I was correct! Oh my god. Fuck. Alright, whatever, it's fine. It's fine. I'll go back and then I'll put that comment back there. The comment was correct. God damn it, dude. It was supposed to be a compliment. I thought it was wrong. Turns out she goes by 2 different names. Unreal. Alright. Long story short, good band. Good band I've been listening to for a while. I'm listening to right now. Alright, let's go. So, yes, we can mix pass by value and pass by reference. So we could do... Yo, yo, yo. There we go. All right. My finger's sticky from eating an apple. I guess I already finished that. I don't even remember. Excuse me. What the fuck? Excuse me. We do avoid. So the planet has some number of stars. It has... I mean, in this case, I mean, this should really be... just more coherent if I do it this way. We can pass this the number of stars. It only has 1, so we can do a we're just passing by value. It's fine. But we could also make this a constant reference and then get the temporary object, the R value. But either way, it doesn't really matter. I don't think. There's already gonna be another object that's created anyways. Well, no, because the temporary already exists, so maybe it actually is cheaper to do constant reference. 1, the moons, and then planet. So we can cheaply pass in a standard string that we don't want to fuck with, which is why this has to be a const, an L value reference to const. And then similarly, we don't want to fuck with the moons nor the stars. And this is an R value too, so we want to access these as cheaply as possible. Cool. Yeah, we've already checked this. Cool. Yeah, because we're passing by value, passing by reference, modifiable value, passing by reference, by const reference, maybe modifiable, maybe not, but we can't modify it. Could also be an R value, but in this case, well, could also be an R value, yeah. But it's not, because standard string, I don't think you can have a standard string R value. Maybe you can, though. Maybe you can do double reference or something. Okay. Yeah, we're passing a literal by value. We're passing a modifiable integer by, we can't tell in the call. We can't tell here, we can tell here. Passing it by an L value reference, and then passing a standard string, a const standard string, by const reference. L value reference to const. So we can specify each one. I mean, yeah, this is what you would do. You would do it, what's expensive, pass by reference, cheap, doesn't matter. Are we dealing with fundamental types and whatever the fuck enumerated type is? Okay. Otherwise, do it by reference, probably. Oh. Sleep, I guess, accumulated in my eye. Zzz. Okay. When to use one versus the other? That was a lot of other information here, I'm surprised. Cool. Fundamental and enumerated types are cheap, pass by value. Class types are expensive. Const reference makes sense because we don't want to fuck with them, maybe. Yeah, makes sense. Agreed. Unexpected behavior because of what? Something being expensive? I mean, I don't know what unexpected behavior you would get. If you were passing standard strings, I mean, it would be more expensive. But what would be the unexpected behavior? Would he run out of memory? I'm not sure. Take more time to execute? Passing by value is actually more efficient to do some things. A view and a span. An iterator or a reference wrapper? Oops. Oh, good. Cheap to copy class types with value semantics. Shit that the function needs to touch. Types that aren't copyable. Oh. So like if the OStream is one thing that exists somewhere and we can't copy it, then yeah. Oh, yeah, because I mean the input stream got disconnected, so we can't just create another input stream if someone enters an EOF character, allegedly. Ownership implications, meaning that if we copy it, we have to do some other shit to actually get the value to go where we want, or if it doesn't like passing its information to other things. Whatever the fuck a virtual function is. Basically things that fuck around when get copied, or they're expensive, pass by reference. So for cheap things that are small, or for small things without extra setup costs, maybe passing by value is best. Meaning it must go to wherever it actually is. Must access the storage location allocated to the reference. What are we saying the extra step is? Meaning, the point is that for a past value, the object is already in a place that the function can access. But the reference is in a place, but then the function actually has to go and access wherever that value is and change it there. So we have to access the reference and access where it's actually going. It's like for me to set up a bomb, I have to have something that triggers the bomb, but I also have to have a system by which triggering the bomb will actually go and trigger the bomb. Compared to just having the bomb here, boom! Instead, I have to go, whoosh, boom. Two different things. So there's extra effort required to access it in memory if we're using a reference. And they like every fucking comment. Holy shit. Meaning if only one thing is accessing, or what is the thing? So if we're using a reference to something, we're talking about an actual other object. And there might be other references to that object, so we need to be careful when optimizing and fucking around with that object. But if we have a copy of the object, then the object was just created. The copy was in this function, it's local. Therefore, we don't give a fuck. Optimize it to hell. Because the real object is fine, even if there are references to it somewhere else. So in short, it seems like references are less prone to, or are more conservatively optimized, meaning more restrictive, rightfully so, with the optimization. Whereas copying by value, or passing by value rather, is more aggressive. So, if something is the same size, if an object is the same size, an object of a given size is passed by value versus reference, then if it isn't, if the cost of copying it was about the same as the cost of just passing it by reference, and the additional cost of the reference accessing wherever the information actually is in memory, then maybe passing by value is better because it can be optimized better by the compiler. But if something is significantly cheaper, even including the additional extra costs of passing by reference, then it probably makes sense to pass by reference. Like a standard string is probably significantly more cheap to pass by reference than it is to pass by value. Therefore, pass it by reference. Always. But if there's some mystery type, then passing by value could be good, even if it's about the same cost of doing by reference, because the reference would have extra costs. What is this? Bro, what do I even have on my fucking computer? For objects that are cheap to copy, cost of copying is similar to the cost of binding, but accessing is faster. The compiler is likely to optimize. Or hold on. For objects that are cheap to copy, the cost of copying is similar to binding, but accessing them is faster, and the compiler is also going to optimize better. But for things that are expensive to copy, then the copy cost is the main thing. So depending on what the copy costs are, if they're similar, maybe passing by value edges. But if they're significantly more expensive to copy, then the cheaper pass by value is better. What is cheap to copy? Are we talking time? Memory usage? What? It uses 2 or fewer words of memory. Where a word is approximated by the size of a memory address. The size of 2 memory addresses. So we do the size of some sort of type. If it's less than or equal to 2 times the size of empty space, I guess. I don't know what a memory address is. Is that... Hmm. So the size of a memory address, the memory address is... How big is a memory address itself? I have no fucking idea. Gotcha. Can't pass a type as a parameter? Gotcha, we can't pass an int. Not an int value, an int. Assume that they do, okay. Really? Prefer string view over a reference to that? Why, less setup? Or is it just a better way? Does it remove the extra cost of going into memory? A wider range of argument types, meaning that there's less... Oh, gotcha. Because a standard string view might bypass the conversion that happens if you pass a C style string, excuse me, to a string view, or a standard string is a string view, etc. There's just less, or it handles the different conversions without having to copy extra shit maybe. A standard string view parameter also allows the caller to pass in a substring. I don't know what that means. Oh, got you. A substring, meaning like a string literal. Meaning if I pass in a string literal, I have to first create a string to put that string literal in, and then pass that. Instead, I can just pass straight up. So it seems like it's more compatible with C style strings, and other types of strings too, maybe, or other arguments, I guess. So when we're talking about a constant standard string reference versus a standard string view, prefer that. Okay. Well, if string view doesn't exist, duh. Or if your function needs to call something and pass it as is already, maybe? Gotcha. It isn't guaranteed to end your standard string with a null terminator, an endline character. So if your other function is going to look at that standard string and check to see if it has a null terminator or how many characters are in it, that kind of shit, where the null terminator is important, maybe doing a reference is good to make sure that we have maximum accuracy. And a standard string can easily convert to a standard string. But if we have a standard string view and we're converting it to a standard string there somewhere and it's using it, then maybe it's weird. Not as efficient. Unless the function calls other functions that require C-style strings or standard strings. Yeah, it'll copy it. Yep. Converting creates a temporary object. Yep. That's good. It just copies itself, which is cheap, not the standard string, which would be expensive. Yep. Makes sense. Gotcha. So if it doesn't match the standard string view, then the standard string view gets copied and converted, not the actual object itself. So the value it's viewing, maybe? So if we pass to a string view parameter, standard string gets converted, but it's not expensive. Standard string view, then the value is just copied over. And the standard string is the same as a conversion. But if we do a string parameter, standard string is just a reference, we're looking straight at it. But if it's a string view, then we have to look at that reference and copy that information into something else, into a standard string. And then a C-style string that we're looking at as an L value. It's not a standard string, so we have to convert it to a standard string as a temporary object. And that might be expensive. Okay. Yeah. Makes sense. So and it's 2 because it has null termination. Why is a string view? Cannot convert a string view to a standard string reference. What if this guy isn't const? Nope. Yeah, oh yeah, it needs to be const because, well, no, because those aren't even R values, those are L values, but okay. Apparently, a standard string view can't even be converted to a standard string, but I don't know. Seems like, and then yeah. Not sure why this isn't working. There's no conversion for a string view to a const standard string reference. Okay. Alright, noted. Basically, standard string cheaply handles these, whereas string reference only cheaply handles the reference to an actual standard string. The copies are expensive. Oh, and it must be an explicit conversion, huh? Okay. Oh, yeah, I see this. Cool. Standard string is converted to a string view. Cheap. It's a string view argument. It just copies value to value. Argument to parameter. Cheap. Standard string. Cheap. But with a reference, okay, cheap binding, cool. String view, we have to copy. And with a string view, we have to explicitly convert it because there's no implicit conversion from string view to standard string. It's a standard string. So because we're copying the string that the string view is viewing into another standard string, which is expensive. So it seems like the copies are expensive, based or the cost of a copy depends on what data or what the type of the object that's receiving it. Yeah. Yeah, we already had to do the conversion first. No bueno. No bueno para nosotros. Pass the C-style string. Yeah, we also convert it. Yeah. And the point is it's expensive to convert shit to a standard string. Yeah, it's the same shit that I did, except this shows the error, this shows the solution. Yeah, versus the extra to get to the RAM. So even if this is cheap and this is cheap, maybe this still makes sense because it's easier to access directly. If I assume that these are the same cost, then we do value all day. Value's just better, period. Okay. Yep. Gonna lock it in here. Sure. Or this object will be instantiated in memory. It'll get a little piece of memory. It'll be put in that little bucket. Say that it gets that memory address. Okay. Whatever that is, 256 plus. Or oh no, that's ones, 16s, and then 256s. Yeah, so 256 plus 64 plus 0, I think maybe. I think that's hex. Oh, I guess it would have said 0x though. Whenever we use variable x in an expression or statement, the program's probably going to go to that spot and get whatever's there, huh? Yeah. In scope. Nice thing about variables is we don't need to worry about what specific memory addresses are assigned or how many or any of that shit. We just use the identifier and it goes. Also true with references. Meaning we could just use ref and it'll say, hey, this ref, this character, this L value reference to a character, a modifiable character, is referring to referent X, which is located at 140. So if we fuck around with ref, we're going to go and fuck around with 140. When used with a type, it's a reference. But I guess if we're using it with an object, then it means the address of. Because ref acts as an alias, whenever we use it, it'll go to 140 exactly. Cool. The address of operator returns the memory address of the operand. It's a unary operator. Okay. Yeah, and that's how we can do the proof that the copies within functions after passing something by value yields another copy, or yields a unique object. I didn't fucking call it. Hold the fuck on. We're printing main X's address, and then we're doing bone. Yeah, it's different in memory every time by a lot. Address of some stuff, dude. Two different things. Okay, I wanted to see what happens when you get the address of a view. Yeah, I guess the view is its own distinct thing, and it's a separate way of cheaply storing. It's like a cheap. I guess that's what it is. It's a cheap view. Oh, and I guess we say it's read only because if we change it, it's not changing the name because it was copied into it. It's a distinct object. So we can still change it. Hmm. Okay. Oh, okay, so it is printed as hex. Alright. Makes sense. Yeah, just like if we do. Last time I did this, the addresses were only a little bit apart. Oh, interesting. So maybe. Oh, it was coincidence, but they're close to each other. In the type name, it says, "Hey, this is a reference." In a unitary expression, it's the address of. Oh, but it's also the and to return a binary. To return. I guess probably an unsigned int. So we say this set of flags, this bit set, and this bit set, and it returns the bits that are positive in both. The bitwise and operator. Okay. useful thing we can do with the address is to access the values stored at the address. Okay, so double and is not the answer here. Double and is just a reference to an R value, it seems like. Indirection operator? Turns the value at a given memory address as an I value, so excuse me. And so I could pass it by reference and then just print the reference, or oh no, because that's a reference. This is the address of operator. So these are two new things. If I have a reference of something, yeah, I can just add something to it or add it with something and change them around and get different values. I don't need to do any dereferencing. But if I get the address of something, so there's no reference or anything, there's just an object somewhere, really a variable so that I can fucking identify it. And with an identifier, I can use the and then the identifier to get the address. But if I want to get the value at the address, so like if I pass the address of something, then I can dereference it to get the actual value. So I could pass the location and then I could. So it seems like maybe you could do the same thing as like a reference. So I could make a reference to a variable. I'm an integer, okay? And then I pass that variable to a parameter as an argument to a function with a parameter that has an integer reference, an L value reference, an L value integer reference, and I could print the value there. But I could also pass the address of the variable, and then I could print the dereferenced version. So what value would I pass? It's like I can out. Is it just an integer? Yeah, I don't know how that's gonna work. Because I'm thinking I need to pass this, so I could call print ref value, and then just pass in x. Or what was it? Fuck. No. There was a better way of doing this. Multi-line comment, where's it at? Toggle block comment. Like that. Okay. So, this prints that, but I want to call print dereference value with reference to x. But I'm not sure how I store that. I was hoping that it could just be a number, but I guess it's in binary, so it would need to be a binary number, but it's also not happy converting it, so I'm not sure. But yes, so if I have an address of, I can dereference it and get the value that's there. And we print the address, and then to get the value at that address that we've just acquired. Given a memory address, we can use the dereference operator to get the value at the address, if we have a memory address. Why we want a memory address instead of a reference, I'm not sure yet. Address of gets the address of an object. Dereference gets the object at an address. Whereas the multiplication is binary, yep. Yeah, it's not useful at all, bro. Let's do 2 more one arms. Okay. What am I fucking looking for? Oh, yeah. No, that's not what I want. Damn. Okay. Oh. Oh. The memory address of a variable. Or yeah, okay. Alright. A pointer is an object that holds the memory address. A memory address is its value. Okay. So now, alright, well. Pointers we were talking to are raw or dumb pointers instead of smart pointers. A type that specifies a pointer is a pointer type, just like a reference type. Yep. Normal int, an int reference, and a pointer to an int pointer. Okay. To a modifiable int. Maybe we can do a const pointer too. Logic is kind of easy because x already is an address of something. And I have to give it an address. Cool, so I can do either. So I can pass it as a reference, or I can pass its address. Doesn't like being const expression. Oh. Because we don't know where it is in memory. This would have to be static, because static tells the compiler where this guy is in memory. Otherwise it doesn't know. Oh, well. Damn. Oh, hold on. Damn it. I was hoping. So before, this is just a pointer to a const expression end, not a const expression pointer. It's a const expression end pointer. Okay. I wonder if a const pointer means that we can't change the information that's there. What would even happen? So if we have an address or something, how would I change that? Do I say that that X is something? Okay. So what if I say that I could say, could I say this Y is 5 now? Oh shit. Isn't that what linked lists are? They just include a pointer as the last index that continues somewhere else. So I could have a piece of memory here, a piece of memory here, here, and they continue like this. Something like that. How do you go back from one? I don't know. Is the first the last one then? X is 4. The address is this. Change the value of X by changing the value of the dereferenced address to 10. Which is the same as, okay, interesting. So I could change it a couple different ways. There's a lot of different things you can do here. Or a lot of different ways of doing similar stuff. So I could have X and I could change X. I could have X and create a modifiable L value reference to X and change X through the reference. I could store the reference or X's or that reference or X's address as a pointer and change the value at the dereferenced pointer, dereferenced address. I can say, hey, here's a guy. I can change the guy. Here's a guy. Here's a way of looking at the guy. I can bind this to him so that if I change this, or really it's like I can through this change it. Or I could say, here's the guy, here's where he is. Find where he is and change him. Beep, beep, beep. So there's different ways of doing it. Similar results. So I could pass a pointer. I could pass a reference. I could assign it by passing value and then returning to assign it. Okay. And I could assign it or initialize it with X's address. Hey, you already said that. You said it right up here. Or rather, here. Much like references are declared with an ampersand, pointers are declared with an asterisk. Therefore, it's not the dereference operator. The dereference operator is a unary operator used for an object, whereas this asterisk simply denotes that this is a pointer to an integer. Yeah, because otherwise it looks like you're dereferencing X. If you lose the type. I mean, not really, but because the type is the important part here. Yeah, that just looks like shit. We say there's an integer pointer, pointer one. Oh, interesting. So really, excuse me, I guess that's why I've seen the pointer attached to the name. Because say we're saying, hey, here's some integer shit. Here's the pointer to an integer. Here's an integer. Versus, here's an integer pointer. Here's another integer pointer. Yeah, that's why it would be used as an argument, placing it next to the variable name. But yeah, true. How about just don't fucking do two variables on the same statement? It looks like shit. A wild pointer because you don't know where the fuck it's pointing? A garbage address, yeah. Yeah, because it's a variable. Or I guess it's a variable holding a value, and the value is an address. So, like, if you initialize an integer and it was a garbage value and it had the value 1284682, but then if you instead had a pointer there, it would get 1484262, something like that. 1484272. I don't know. 262, 27. I don't know. It would be instead a pointer to that. Instead of having that value, it would actually be a pointer to that address. Yeah, initialize them. Oh, that's how we do a null pointer. We just value initialize it. Cool. Wonder if that's the same as just pointing it to 0. Cool. I think. And then That's why I keep doing it. Yeah, makes sense. Dang it. Still not happy. It doesn't even want to tell me the address or what's there. What are the secrets? I want to know what's at the secret address. Gotcha. Well, yeah, like, hmm. Name is Ethan. Value at the name's address is Ethan. Cool. We have a pointer holding the address of another object. Then we can use the dereference operator to address the value at that address. What if we did some meta shit? I don't know, does it work? Oh fuck. Is this a pointer to an end pointer? Ah! Damn. I wanted this to be a pointer to an end pointer, and I wanted it to point to the address of itself. Fuck. We have integer x, x. Pointer to an integer, getting the reference of x, outputs the value of that. So it should be 5, 5, yeah. Memory address has the value 5. Pointer stores its address. X pointer is commonly, so we say an integer pointer, we mean a pointer to an integer. I mean, that's what we would expect. If we say a constant pointer, I would assume we're saying a pointer to a constant integer. But maybe that clutters the language when we're talking about a constant pointer, meaning that a pointer that can't be changed, so a pointer that you can't use to dereference something. I don't know, maybe? Like a read-only pointer? Or I guess that's what we had earlier. Okay. Oh yeah. But if I made this const, then it's gonna complain because this, oh, it's actually okay. Nice. So a const int pointer. This is a const int pointer. But if we do a const oh, okay, it doesn't work. Okay. Oh yeah, and then it also needs to be static. And then I also just can't assign it. Okay, there's some other fun semantics I'll get into. So what happens with conversions though? Like if I assign, what happens if I have a const integer and I make a pointer to an integer and I get the address of a const integer? Will it say that it must be a modifiable value? Can't lose const. Makes sense, because then we could modify it maybe through that. So yeah, that makes sense. So we have an integer I and a double D. We can't have an int pointer or int pointer pointing to an int pointer pointing to a double, probably not good. Double pointer pointing to a double, probably good. Double pointer pointing to an int, maybe not good. Gotcha. So they have to be specific. Oh my! Alright, well we're done for now. Take like a 3-hour break or something and then do my final test. Cool. Alright, done today. Or well, done with the learning part today. I'll do my testing later. Cool. I like this strategy a lot. Pointing. Jesus Christ, dude, I'm talking about programming so much. So much talking. So my throat's dry. That makes sense. Forget that I talk a lot when I record. Feels good. Feels like I'm internalizing the stuff. Soon. In a few months, I'll make some really cool shit. How much longer do I have? Oh, wow. I still have a while. I still have all of July and all of... Holy fuck! April, May, June? I'm only halfway into C++ Foundation, so I have 3 full months left. All of July, all of August, and all of September of C++ Foundation. And then October, November, December, January, February, and March to make a portfolio. And then get hired, work with a studio for a VR, a little indie studio, hopefully VR, for at least a year, and then do some really cool shit. Get as many hours in at C++ as possible, or in whatever's needed so I can become a fucking amazing. All right, cool.